Okay, so our purpose today is to be able to write and solve equations using two variables. So even though there's lots of with is fine, yes. If you want with here, with. That's fine too. Even though there is academic vocabulary there, the truth of the matter is everything in it we have defined before. The new layer to the problem where everything gets a little deeper, a little bit harder, is that this time our equations will have two variables. So that's kind of, if you're like, okay, if that's what I got to solve today, if that's what I've got to figure out today, that's the goal, is understanding that an equation can have two variables and then what to do with them. How to solve when there's two unknowns. Most common that you're going to see in problems is that they use an X and a Y. So that's, if you're looking at different problems, it's very common to see that they would use both of those. And that's nice because when we're solving an equation with two variables, our solution is always going to come in the form of x, y. Our solution, there's going to be two solutions because there were two variables, and the solution will then come in that form of an ordered pair. And so when they use an x and a y, it makes it a lot easier to be able to put it right into the ordered pair. It just makes it go smoother when they use those two variables. If they use other variables, then you have to figure out which one was taking the place of the x and which one was taking the place of the y. And we'll talk about that today. In this situation, the x, the first spot right here, that x is always the independent variable. Which means that the y is the dependent variable. The y depends on what x is. The x doesn't depend on anything except the situation. So, but the y depends on the x. So you might see a problem that looks kind of like this. Y equals 8x plus 1. First thing I want to check is it an equation? Is that an equation? How do you know? Brandon? There's an equal sign. And if it's an equation, it means there is a solution. We can solve this. But when you look at it, you go, well, I don't feel like I have enough information to solve it. It was so easy when we put a number here. Then we could solve it. This time we're putting another variable there. So I'm going to talk you through how you would do this. The way you start to solve a problem like that is you make the T-chart, put the x on the left, the y on the right. The x is the independent variable. The y is the dependent variable. And then, and this was the thing that I know when I first learned how to do this, it just flipped me out. I couldn't wrap my brain around it. So I'm hoping to teach it in a way that you guys can, and so that you don't have the same problems I had. Because I totally, okay, here's my equation, and I could draw my T-chart, and then I went, got nothing. What do I put in it? I have no idea. There's nothing in there to put in it. And it took me a long time to understand I get to pick. It is up to me what I put in it for x. Y will depend on what I choose for x. I can put anything I want for x. So I want to teach you how I look at it, because you know I'm all about the shortcuts and making it easier for myself. I always start with 0, because 0 is little, and it means that I'm going to keep my numbers small. So I always put 0 in as my first thing for x. And then I go back up to the equation and I put the 0 in for x. So this then would read 8 times 0, right? Because they're next to each other. What's 8 times 0? 0. Plus 1. So if my x is 0, the y is 1. The y depended on the x. So that's not so bad. And now I'm not done yet, though. I can't just do 1 point. Because the deal with these equations is there are lots of solutions. Because I could put anything I want in for x, and there will be a y answer. So now I'm going to put a 1 in. Again, just always going for the little numbers. So if I put 1 in for x, 8 times 1 is plus 1. If x is 1, y is 9. You doing okay so far? Yep. All right. Just like a scientist, I like to put 3 numbers in. Because you know how a scientist runs a trial 3 times? By getting 3 numbers in, I'm double checking that I did it right. So if I did a 0 and a 1, hey, what's wrong? If I have to put one more number in, what am I going to pick? 2, right? So put a 2 in, and what do I get for y? 17. I'm hearing 17s all around the room. 17. All right. Everybody's good so far? See, then I have to graph it, and I'm going to draw my graph, and I'm going to let the first quadrant be the largest, because I noticed that all of my points fall in the first quadrant. They're all positive. So if I say, okay, so I'm at 0 and I go up 1, I'm not going to go up very high for 1 because I have to go all the way up to 17. So here's my 0, 1. Then I go over to a 1, and I have to go up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to count this as every line is worth like 3 in mine. All right. Then I have to do 2, 17. 2. So now I'm going to go up. This was 9, 10, 11, 12, 13, 14, 15, 16, 17. What does this look like then? What is it going to be when I play dot to dot? When I connect them? It's a line. And so then I draw my line, and an equation will be a line. And in fact, I can name that line. This line's name is y equals 8x plus 1. That's the name of the line. At that point, I've basically done everything I can do with the problem. I've tried some points in. I figured out what the y would be depending on the x, and then I graphed it. Is there a solution that wouldn't work? Is it possible to have something that doesn't work? Any number that doesn't fall on the line doesn't work. The line is the solution. Every point that's on that line works, and every point that's not on the line doesn't work. So like looking at this, it looks to me like 2, 1 doesn't work. So let's try it a second. 2, 1. I'm going to try that point. Put 2 in for x, and I get 16 plus 1. No, the point that works is 2, 17. 2, 1 doesn't work. This doesn't solve. Kayla.
Can you multiply
Yes, great question. Now, I told you, I always go for the easiest answer. So what I tell Brooke and Ty at home to do is the three numbers I tell them to choose every single time, -1, 0, 1. Because that way, I'm keeping my numbers as small as I can, but I'm checking to see, can it ever go negative? And if I do a -1, now you could do it on your calculator, but I know in my head that 8 times -1 is -8. And then plus a 1 would actually give me, so -8 would take it to a -7. So if I had put -1 in, my answer would have been -7. So that would have been the point that's down over here. Still falls on the line. So absolutely can work. All right, couple other situations that I just want to check. One more just total example, just like we just did. Make sure you're set. So here's an equation. Y equals 4x minus 3. How do I start? What do I do first to solve this? Caleb, what do I do first? I draw my cheat chart. And where do I put the x? Where do I put the y? Caleb, keep going.
Put the x on the left.
X on the left, y on the right. Because that's going to set up my ordered pairs. So now I have to start. I'm going to start with 0. Low numbers. 0. 0 times 4 is 0. 0 minus 3? -3. Ooh, I already got a negative number, so I really don't even have to go negatives with my x's right now. I'll be fine. So what do I want to put in next? 1. 1 times 4 is 4. 4 minus 3 is 1. I'll throw a 2 in there just to double check where I'm at. 4 times 2 is 8. 8 minus 3 is 5. I now have 3 points. Draw my grid. And I'm going to graph 0, -3 is going to be right here. 1, 1 is going to be right here. And 2, 5 is going to be right here. And my drawing's not perfect. If it were perfect, that line would line up even better. And I can name that line. It's y equals 4x minus 3. And I'm done. This is the solution to the problem. The equation can be solved. It's all of those. Every single point that falls on that line, which is almost like infinite number of points, right? Because lines go forever. Here are some possible solutions. There are infinite solutions, but they have to fall on the line. There are things that don't work. No, enough to draw the line. It takes 2 points to draw a line, a third point just to double check that I'm on the right path. All right, last thing that can happen. So far, so good? You seem very with me for as hard as this is. Last thing is, this is awesome when they give me my equations with x's and y's. It makes it so easy. But life doesn't go that way. So here's a real situation that could happen. I pay babysitters, which I don't even use anymore, $8 per hour. That's a real life situation, right? Yeah. I pay babysitters $8 per hour. So how much do I pay the babysitter? What? Say it louder. There's an important word he said. It depends. Oh, so the amount I'm going to pay depends on hours. So which ones? So I know I've got a T-chart again. It depends on how many hours they work. So is the pay the dependent variable, or is the hours the dependent variable? The pay, so think of it this way, does the pay depend on the hours, or does the hours depend on the pay? The pay depends on the hours. However long they're there, that's how much I pay them. It depends how long they are. So the pay depends on the hours. That means the hours is the independent variable, and the pay is the dependent variable. If they worked 0 hours, I pay them $0. If they work 1 hour, they get paid 8. What if they were there for 5 hours? They get $40. All right, just to stretch your little brains as far as I can, what if they were there for 2.5 hours? Is that possible? Could that fall on the line? JT? $20, because they would get 2.5 times 8, which is 20. Which means that this bizarre point falls on the same line as these points. Is there a solution that doesn't work? Of course. If they were there for 3 hours and I hand them $10, it doesn't work. It's the reason why a babysitter might get angry. Because they got $10, but they were there $3, and they thought the formula was $8 per hour, and that made the formula look like it was like $3.33 per hour. So there's lots of things that don't fall on the line, but there's also lots of things that do. Could a negative fall on this line?
No.
Why? Brandon.
Because she gets paid $8 an hour. What if she hurts the kid?
Oh, no. Remember, I'm always going to put the time in first, and I'm saying, could I put in a -1 on this one? Kayla?
No, because
Time doesn't go backwards. You don't pay somebody for coming for a negative hour. You didn't pay them for the hour, I guess, that they were getting ready or whatever. So there's not going to be negatives, which means there won't be negative pay. The formula on this one, if I were to write the equation, would look like that. The pay is 8 times however many hours they work. All right. Today, you're going to get out your journal, and I want you to turn to page 163.